Today, 4.4, we are going to be graphing function rules. The other day we mentioned this already once. I'm going to mention it again. If you have y equals and something is only to the first power or x to the first power, this is linear. It makes a straight line. Okay? If you have y equals x squared, as soon as you see that it's x squared, you know that your graph should make a U. If we have y equals x to the third, I told you this reminds me of an S-curve on a road. Kind of does one of these deals. I also said that if we have something that is exponential, so we have a number to the x power, that graph is increasing on a curve. And the last one we're going to talk about today is y equals the absolute value of x. The absolute value of x makes a V shape. So when you go to graph them today, if your shape, when you graph them, it doesn't look like what it's supposed to, check your math, right? Don't just leave it. Check your math. So here's the deal for today. 1. Make a table of values using -2, -1, 0, 1, and 2. Step 2, plot the points. Step 3, connect the dots. So now if it's a real life situation, it's going to be a little bit different, but we're going to start with not using a real life example, okay? So, example number 1, following the same idea. You're going to want to graph y equals 2x minus 3. So we're going to make a table. In our table of x and y, the values we are always going to use are -2, -1, 0, 1, and 2. We're going to take those values and plug them into our equation. So we have 2 times -2 minus 3. 2 times -2 is -4, minus 3 is -7. Then I plug -1 in for x. 2 times -1 minus 3. 2 times -1 is -2, minus 3 is -5. Then I have 2 times 0 minus 3. 2 times 0 is 0, minus 3 is -3. 2 times 1 minus 3. 2 times 1 is 2, minus 3 is -1. And the last one I have is 2 times 2 minus 3. 2 times 2 is 4, minus 3 is +1. So then you're going to graph it. Now, before I graph this, because x is to the first power, this should make a line, right? That is the point. So I'm going to plot the point -2, -7. -2 means I go to the left 2 and I go down 7. 1, 2, 3, 4, 5, 6, 7. Put it at. -1, -5. I go left 1 and down 5. Put it at. 0, -3. 0, -3. 1, negative 1. I go to the right 1, down 1, and 2, positive 1. To the right 2 and up 1. Then I connect my dots. Well, hopefully a little bit straighter than that. There we go. This does make a line. Questions? We're going to use those same points every single time today. All right. So here we go with example number 2. This is exactly what you are doing for 10 through 20. Graph the function rule. All right, so let's go with y equals negative 1/2 x plus 1/2. Had to throw a tougher one up here. First of all, what values are we going to use for x? Very good. Negative 2, negative 1, 0, 1, and 2. So we're going to start by plugging negative 2 in for x. So I have negative 1/2 times negative 2 plus 1/2. Negative 1/2 times negative 2, positive 1, plus 1/2 is 1.5 or 1.5. Again, you can use your calculator to find those, right? Negative 1/2 times negative 1 plus 1/2. Excuse me. Negative 1/2 times negative 1 is positive 1/2 plus 1/2 gives me 1. Negative 1/2 times 0 plus 1/2. Negative 1/2 times 0 is 0, right? Plus 1/2 is 1/2. Or 0.5. Which way do you guys want me to write it? 0.5? I can write it as 0.5. Yeah, so, but we're going to be graphing it as technically, like, so when we go to put it on a graph, because it's 1/2 or 0.5, we're just placing it. Either one's fine with me. That's why I said I didn't matter which one you wanted. So the next one, if I have a negative 1/2 times 1, which is a negative 1/2, plus 1/2, gives me 0. And the last one, negative 1/2 times 2 plus 1/2. Negative 1/2 times 2 is negative 1 plus 1/2 is negative 0.5. All right, now that I have all my values in my table, excuse me, we are going to plot these. So the first one is negative 2 and up 1.5. So I go left 2 and up 1.5 or 1.5. I have negative 1, 1. So I go left 1, up 1. I have 0 and 0.5. So I don't go right or left, but I go up 1/2. I have 1, 0. And then I have 2 and down 1/2. You can see that is linear. It makes a line. I'm going to go ahead and connect my dots. All right, so this is what we're doing for the first section. And I will tell you all 10 through 20 are all linear. They should make a line in the first section. Okay? I want to talk about some real-life situation, and then we're going to talk about some of the other ones. So, if it is real life, a couple things I want to tell you about. First of all, if it is discrete, that's not a very good I there. Let me try that again. Discrete is where you do not connect the dots. Okay, so something that's discrete, you can't have a partial of, right? Like we couldn't buy half a can of pop or half a can of soup, or you wouldn't buy half a pair of jeans, right? Okay. If it is continuous, that means you can have partial in between, and we do connect the dots. All right, so those are two different vocabulary words we're going to have in the future coming up here. And values for a table would be 0, 1, 2, and 3. Okay? Because we're talking about real life. The chances of us going negative or back in time don't make any sense, right? Do not make any, yeah. Anyway. All right, so here is an example. Example number 3. This is similar to what you are doing for number 22. Graph the function rule. The total cost of see what I want to say. Ordering, you guys, come on. Jeans is $10 for shipping and $23 for each pair. And I'm going to tell you that the function rule is C equals 23J plus 10. So I'm already giving you your function rule. What we need to do is graph it. So over here, this is going to be the number of jeans. This is going to be my cost. So I have 0, 1, 2, and 3. If I plug 0 here, 23 times 0 plus 10 is 10. Try again. Next one, 23 times 1 plus 10 is 33. 23 times 2 plus 10. 23 times 2 is 46, plus 10 is 56. 23 times 3 plus 10. 23 times 3 is 69, plus 10 is 79. All right, so over here, when I go to graph it, I'm going to have 1, 2, 3. Now, I'm going to be going up by, let's go by 10s. 10, 20, 30, 40, 50, 60, 70, 80, and 90. First one is at 0, 10. So I go 0, 10, I apply here. Next one is at 133. So 1 about right here. 2, 56, 2, and up to 56. And 3 and up to 79. So up here. Now my question is, obviously these make a line. Am I going to want to connect these dots? I agree. Why not, Nicole? Correct. So this will be considered discrete. Okay? One of the questions that will be on your test on Friday is this discrete or continuous? Well, obviously this is discrete. You can't connect the dots. That's one of those things we're going to talk about. All right? Just got a couple more examples, and I'll get to let you guys get started. Now we're going to talk about some of those other ones that are nonlinear. So here's example number 4. This is in that final section, 24 to 32. Graph the function rule. All right, let's do y equals the absolute value of x minus 2. So over here in our table, it is not a real life situation, so the values we use are -2, -1, 0, 1, and 2. Now before we get started, what shape should this make when we're done? Oh, not quite. A V. Very good. There you go, Ashton, a V. Perfect. Okay, so let's see if we get a V out of it. So we have the absolute value of -2 minus 2. Well, the absolute value of -2 is +2. Minus 2 is 0. Absolute value of -1 minus 2. Absolute value of -1 is 1. Minus 2 is -1. Absolute value of 0 minus 2 is -2. How about the absolute value of 1 minus 2? What's that one? -1. Good. And the absolute value of 2 minus 2 is 0. All right, let's see how we did over here. All right, the first one I'm going to plot is -2, 0. So I go left 2 and right on the line. -1, -1. I go to the left 1 and down 1. Yep, the y. Yep, those values we found. So I'm doing the point 0, -2. So 0, -2. I go, this one is 1, -1. So I go to the right 1 and down 1. And then I have 2, 0. So over 2 and right on the line. If I go ahead and connect my dots, it should make a V, just like Ashton said. Okay, so if it has an absolute value of x in it, that's what it should be doing. All right, let's try this one. Last one. Example number 5. Again, this is from the 24 through 32. Graph the function rule. And let's do y equals 2x squared minus 1. All right, so again, the numbers we use over here are -2, -1, 0, 1, and 2. That's always what we're going to use. Let's real life situation every single time. So first thing we're going to do is take this -2 and plug it in for x. So I have 2 times -2 squared minus 1. So this is very similar to our warm-up, which we didn't do well on. -2 squared would be +4 times 2 is 8 minus 1. So this equals 7. We're going to plug in -1. So I have -1 squared is +1 times 2 is 2 minus 1 is 2 minus 1 is 1. Here I have 2 times 0 squared minus 1. 0 squared is 0. Times 2 is still 0. Minus 1 is -1. This is 2 times 1 squared minus 1. 1 squared is 1 times 2 is 2. Minus 1 is 1. And the last one, 2 times 2 squared. Minus 1. 2 squared is 4 times 2 is 8. Minus 1 is 7. All right, we're going to graph this. So before we graph this, what shape should this one make? Got an x squared in it, so it should make a what? A u. Very good. All right. So when I plot my first point, I am plotting the point negative 2, 7. So I go left 2 and up to 7. Then I have negative 1, 1. So I go left 1, up 1. I have 0, negative 1, which means all I do is go down 1. 1, 1. And 2, 7. So over 2 and up to 7. So you can see that it's supposed to make, there you go, a U. If I tried to make straight lines, right, if I tried to make it into a V, these would end up coming out to here, so there's no way that makes a V, right? Okay, any questions? All right, so here's the deal. We are on, let me turn this off.